Welcome to the 12th part of Thermal Properties of Matter. In this part, you will learn about Stephen-Boltzmann law, Wien displacement law, and greenhouse effect. Wien's displacement law. The total energy radiated by a black body is not uniformly distributed over all the wavelengths but is maximum for a particular wavelength lambda m, and this value decreases with increase of temperature. And the Wien's displacement law states that the wavelength lambda m corresponding to which the energy emitted by a black body is maximum is inversely proportional to its absolute temperature T. Mathematically, lambda m is inversely proportional to 1 by T, or lambda m into T will be a constant, and that constant is the Wien's constant denoted by small b. And the value of this Wien's constant is 2.9 into 10 raised to power minus 3. Illustration for the Wien's displacement law. When an iron piece is heated in a hot flame, its color first becomes dull red, then reddish yellow, and finally white. And it is in accordance with Wien's law because with increasing temperature, the emission of energy is maximum corresponding to the smaller wavelength. Importance of Wien's law is that it can be used to estimate the surface temperatures of moon, sun, and other stars. Light from the moon shows a maximum of intensity at lambda m is equals to 14 micrometer, and by applying Wien's law, the temperature of the surface of moon comes out to be 200 Kelvin. Similarly, you can find out for any other star. Stephen-Boltzmann law. This law states that the total heat energy emitted by a perfectly black body per second per unit area is directly proportional to fourth power of the absolute temperature of its surface. Mathematically, E is directly proportional to T raised to the power 4. And when you will remove the directly sign, you will get a constant, and that constant is denoted by sigma, which is a universal constant called Stephen-Boltzmann constant. If H is the rate of radiant energy emitted by black body of surface A, then the Stephen-Boltzmann law form will be H is equals to E into A. And by putting the value of E, sigma T raised to power 4 A. This relation was first deduced experimentally by Stephen and later proved theoretically by Boltzmann, and hence is known as Stephen-Boltzmann law. In terms of SI unit, the value of sigma is 5.67 into 10 raised to power minus 8 joule per second per meter square K minus 4, the Kelvin minus 4. And in terms of CGS unit, its value is 5.67 into 10 raised to power minus 5 arc per second per centimeter square Kelvin minus 4. If a black body is in an enclosure at temperature T0, then the rate at which the black body absorbs radiation from the enclosure is sigma T0 raised to the power 4. and therefore the net loss of energy by the black body per unit time per unit area will be sigma into t raised to power 4 minus t naught raised to the power 4. And if the black body is not perfectly black, then it must have some emissivity. Then the above relation will be E is equals to E epsilon, you can also say sigma t raised to power 4. That is the epsilon is the symbol for emissivity. Here is the energy distribution of a black body spectrum. You can see the visible region and the variation of wavelength at different temperatures. Conclusion drawn from the black body spectrum are: at each temperature, a black body emits continuous heat radiation spectrum, and that is no energy is not distributed equally among all wavelengths. The energy associated with a radiation of particular wavelength increases with increase in temperature. As wavelength increases, the energy emitted increases, reaches a maximum for a particular wavelength lambda m and then decreases. And the wavelength lambda m of maximum emission shifts towards the lower wavelength side as the temperature of the black body increases. Means lambda m into T is constant, and this one is the Wien's displacement law. Area under the curve represents the total energy emitted by a perfect black body per second per unit area over the complete wavelength range at that temperature. And this area is found to increase with fourth power of absolute temperature. And this is Stephen Boltzmann law of heat radiation. The black body radiation curves are universal. They depend only on the temperature and not on the size and shape or material of the black body. Greenhouse effect is the phenomena which keeps the Earth's surface warm at night. You can see the phenomena in the diagram. The radiation from the sun heats up the earth. Due to its lower temperature, the earth re-radiates it mostly in the infrared region. These infrared radiations cannot pass through the lower atmosphere and get reflected back by gas molecules. Low-lying clouds also reflect them back to the earth, and these radiations heat up the objects on the earth's surface and so keep the earth's surface warm at night.